Hello there, welcome to this channel. Okay, in this video I am going to present the answer and discuss the questions. Okay, this is the chemistry paper 4. It is 41 May June 2020. The time is given is 1 hour and 50 minutes. Okay, now we go to the question number 1. Okay, this is the question 1. This question is about elements X, Y and Z. An atom of element X presented as 34 and 16. This is the X, okay? So what are the different types of particles found in the nucleus? So as we understand, inside the nucleus we have a proton and nucleus, and around the nucleus we will have electrons, okay? So they are asking the inside the nucleus, so your answer here will be protons and neutrons. Okay, and this is a 2 marks for you. Okay, what is the term for the total number of particles in nucleus? So we will call it as a nucleon. Nucleon number. So if you want to know more, the nucleon number represents the symbol big N. Okay, so now we go to the A3. What is the total number of particles in nucleus of an atom? So the 34 represented the nucleon number and the 16 represented by the proton number. So the number of particles in nucleus is 34. Okay, now what is the electronic structure of, okay, this is an ion, okay, ion. So if you look at here, 16. So the 16 here, 16 electrons, which I take it from here, this part, okay, 16. So they have a structure of a 2.8.6. Since it is an ion, they borrow another 2 electrons extra. So you will have here 2.8.8. So this is the electronic structure. Okay, let me scroll down a bit. Okay, so here we have a few more questions. Okay, now suggest the formula of a compound formed between aluminium. Okay, aluminium is symbol is a Al and 3 positive. The X is already given here. X is a 2 minus. So we cross multiply, we just take the 3 and the 2. Okay, so the Al will have 2 and this 3 will move here. It will become X3. It represents the number of aluminium and also the X. Alright, so scroll down even further. Okay, here we are with the B, 1B. Okay, what term is used to describe atoms of the same element with different number of particles in nucleus? So we will call it as isotopes. Okay, identify the atom against which relative masses of all other atoms are compared. So you can say is a 12C, the carbon 12, or you can put your answer as a carbon dash 12. It represents the number of nucleon for the carbon. Okay, alright. Okay, what is the name of the amount of any substance that contains this? So it means 1 mole. Okay, 1 mole, or you can say a mole. A mole is a measurement in chemistry that has this much of particles. Okay, so the constant, this is Avogadro's constant, has a name. Name the constant. So the name is Avogadro. Avogadro's constant. Avogadro is a scientist's name that who discovered 1 mole is equals to this. Okay, so next we move on with the next question. Okay, question C. Part of a definition of relative atomic mass is the average mass of naturally occurring atoms of an element. So some of the relative atomic mass are not whole number. Okay, element Y has only 2 different types of atom, Y69 and Y71. So they have this ratio. So what happens is we make it into fraction. This is Y and this is 71, and here will be 3/2. Okay, so to calculate the relative atomic mass of Y, they have a calculation where the 69 you times with 3. So it means 69 you times with 3, and then you plus 71 you times with 2. Okay, and then you have to divide the total ratio, which is 5. 2 plus 3, you got that 5. Okay, let me calculate here. Okay, 69 times 3, 71 times with 2, so you'll be getting the 349 over 5, and you'll be getting, after divided with 5, you'll be getting the 69.8. Okay, so your relative atomic mass is 69.8. Okay, they're asking us to identify element Y. So if you notice that example, I take aluminium, which has a 27 and 13. Okay, so this is the nuclear number of this aluminium is what is a RMM. Okay, so just to this your information, extra information. Now we are going to take this example and answer this question. So now we have to find a periodic table. Which element has this 69.8? Okay, now let us go to the periodic table here. Okay, this is the periodic table. As you can see, the elements has been arranged in this periodic table based on this increasing proton number. So we have to find 69.8, and you can see this gallium. You can see my arrow here, the pointing here. All right, so they have a 70. Which is the nearest to the 69.8. So this is the element Y. Okay, so gallium, Ga or gallium. Okay, now we go back to the question. Okay, so we can put here gallium, Ga, or we can write it as a full gallium. Okay, now we move to the next question. Okay, here element Z is in period 3 and group 5. Group 5 is a group 15 here. Okay, group 15, and here's a period 3. Okay, now the one is a period 3, so which is we just have to calculate here 1, 2, 3. It should be around here, and then it's a group 15, so V. So your calculation here will be is phosphorus. Okay, so this is your answer, phosphorus. Now we go back to the question. Okay, we can write here P, or we can write in a full phosphorus. Okay, now the next one. Explain in terms of electron transfer why Z behaves chemically as a non-metal. So when we break this, okay, they have a 15. Their electron number is, okay, phosphorus electron number is 15e. Okay, there. Then we make it into a electronic structure, you got that 2.8.5. So they will have to accept another 3 more, and they'll become a 2.88. So they have to accept electrons. So the equation here will be P plus with 3 electrons. They accept here. Okay, they accept. And here you have a negative charge of phosphorus. So we have to bear in mind that all metals must be in a positive ions or cation, and metal normally they will donate electrons. So you can say here the reason why this is not a metal is because number one is phosphorus gain electrons to form an ion. So you got the 2 marks there. Okay, so we have completed the first question. Now we're going to the second question. Okay, this is the second question. Okay, magnesium is a metal. Name and describe the bonding in magnesium. Okay, all metals, they will have a bonding. We call it as a metallic bonding. Metallic bonding. Okay, what is metallic bonding? If you look inside the metals, right, the bonding here will be, so let me just draw here. So magnesium is formed by 2 positive, right? So here we have like magnesium, all these positive ions one side. Okay, I just draw few. Okay, so here will be like 1, 2, 3 and 4. Okay, and around these cations we will have a lot of these electrons around. Okay, around. So this is what we call it as a metallic bonding, because the positive and the negative, they will have a very strong attraction forces between them. Okay, so description of this bonding, we can say strong. We say strong electrostatic force, force of attraction between these cations, or you can say it's a metal ions and C of electrons. Okay, C of electrons. Okay guys, so this is the answer, and this is metallic bonding. Okay, so you answer this metallic bonding and a description about it, you'll be getting here 4 marks. Okay, now we move to the next question here. Okay, magnesium oxide is formed when magnesium burns in oxygen. Alright, so complete the dot cross diagram to show electron arrangement of the ions magnesium oxide. Okay, these are the ions. Alright, so here magnesium has 12 electrons, so which means they have 2.8.2, and they will donate these 2 electrons and become 2 positive. Okay, when magnesium changes to iron, they only have 10 electrons, which is 2.8. And if you can see here, the inner shell has been drawn. They have already drawn the 2, so we just have to add on another one more line over here. Okay, one more circle here, which shows the second period, and we can put here the dots, 8 dots. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's it for your magnesium. And then we'll be doing the same thing for oxygen. Oxygen has 8 electrons, which means it's a 2.6. So they will accept another 2 more electrons, and they'll become 2 negative. And these 2 negative, they will have an electron arrangement of a 2.8. So same thing goes to here. We draw another one more circle. Okay, and then we just have to follow this electron. They put X. We just like put here X as electron. 1, 2, 3, 4, 5, 6, 7, 4. Okay, so this is a drawing which will give you 3 marks. And then they mentioned there what are the chemical equation for the reaction that occur when magnesium burns in oxygen. So you'll be having there magnesium we plus with oxygen. Make sure you write here the gas. Okay, O2, it means the gas. So they will form magnesium oxide. Now we have to balance this. Okay, we have to balance. So O is 2, so we put here 2. Now magnesium is 2, so we put here 2. So you'll be getting here 2 marks. Alright, so now we move to the next question. Okay, so here magnesium oxide also forms when magnesium nitrate is heated strongly. Okay, always remember, when nitrate salt heated strongly, they will produce nitrogen dioxide and also oxygens. Okay, so this is an endothermic reaction. They absorb heat. Okay, they need to write the chemical equation for this reaction. So we take this magnesium nitrate. Okay, put here, because magnesium nitrate, let me explain to you in further detail. This is nitrate ion, this is a magnesium ion. So that's how we got here the 2. Okay, so they will heated strongly and they will form magnesium oxide, MgO, and not forgetting nitrogen dioxide plus with oxygen. So this is your full equation, and we have to balance this equation. Since nitrogen, they have 2 at this part. Okay, 2. If you put here 2, if you, let's say we just put here 2, magnesium 2, oxygen is going to be 6. Okay, oxygen is going to be 6. So here we'll be having 1, there is 4 oxygens, and here we have 2. So altogether we have here is about 7 oxygens, and here is about 6. So we cannot put the 2 over here. So what you're going to do, we have to erase this 2. Okay, and then we start back. We put 2 here, and then we balance back the equation. So you'll be having 2 magnesium oxide, and then your nitrogen here will be, here's 2, multiply with another 2, so here you'll be getting 4 there. So your total oxygen here will be 12. Here's 8 oxygens, plus with 2 here, so you're getting 10. So here we just have to put there 1, we don't have to put. Okay, so the equation has been balanced, and you are getting here 2 marks. Okay, when it is heated strongly, the best type of reaction here is We call them as a thermal decomposition. Okay, name two other compounds of magnesium that forms magnesium oxide when heated. So two form. It can be magnesium. Let me write it in full. So here we magnesium carbonate, and another one you can say is a magnesium hydroxide. So okay, both of these, they will form magnesium oxide when they are heated. Okay, so we have completed the second question. The total for the second question is 14 marks. Okay, now we will move on with the question number 3. Okay, now we are here in the third question. Okay, sulfur dioxide is used in manufacture of a sulfuric acid. Okay, this is we have a name for this process. We call this contact process for your information here. Okay, contact process. Okay, in the first stage of the process, sulfur dioxide is obtained from sulfur obtaining ores. Okay, this one is a zinc blende. The raw material that is used to extract the sulfur. Okay, we call it as a zinc blende. Or in a formula they have zinc and sulfur. Okay, so this is the ores. So it's 1 mark over here. Okay, now we scroll a bit. Okay, the next stage of the process, the reaction which can reach equilibrium. Equation for this stage is shown. Okay, this is a sulfur. This is a sulfur trioxide. Okay, this symbol describe two features of an equilibrium. Okay, this symbol represents, the first thing is the reaction is actually reversible. Okay, so I just write it first. The reaction is reversible. Okay, the reaction is reversible means the reactants can form the product, and the product can also go back as a reactant. All right. So this equilibrium sign is also shows that the asks 2, right? The rate of forward reaction. The forward reaction is equals to rate of reverse reaction. Oops. Okay, rate of reverse reaction. Okay, this is the meaning of this equilibrium. All right. So name the catalyst used in this stage. Okay, this part is a kind of critical, and you have to remember the catalyst. Okay, so here the catalyst is used is vanadium 5 oxide. 5 oxide. Okay, and then they'll ask you why is catalyst used. To increase the rate of reaction is your basic answer. Okay, to increase the rate of reaction. So you are getting here 1 mark. Okay, we move on with another question here. Okay, explain in terms of particle why high temperature increases rate of reaction. Okay, so in these 3 marks here, we need to have 3 points. Okay, so you can say, first point here, you can say the atoms, or you can see the particles. The particles will have more kinetic energy. Okay, will have more kinetic energy. So their rate of collision, between reactant, will increase. Okay, then lastly, when the rate of collision between the reactant increases, so there is a high probability that the particles have energy greater than activation energy. So you can say that more particles will obtain higher energy, or you can say energy greater than activation energy. Okay, activation energy. Alright, okay, just bear in your mind that, so this is the key point we need to have. Okay, rate of collision will increase. The particles will have more kinetic energy, and more particles will have energy greater than activation energy. So this is your keywords that you have to understand in a rate of reactions. Okay, next we are moving to this V. Okay, in this stage, only a moderate temperature of 450 is used. Suggest why. What does this suggest about the forward reaction? Okay, forward reaction is about, okay, so this reaction is about exothermic. Okay, this exothermic, meaning of exothermic is the heat to the surrounding losses is more. So that's why they got mentioned here, only a moderate temperature is used, because if they use more temperature, they heat it up more, the outgoing, okay, the heat energy that is outgoing will be more, because this reaction is an exothermic. Okay, now we are going to the next question here. Okay, calculate the percentage of sulfur in a sulfur trioxide. So what you have to do is sulfur divided by sulfur trioxide. So these are the formula. So we have to calculate the based on this RMM. So sulfur is 32. Okay, so here I put a bracket, 32 plus with oxygen is 16. So 16 multiply with 3. So you are getting that 32 over 80. So when they are asking about percentage, we have to multiply 100, and we are getting here about 40%. Okay, 40%. So that is your answer here, 40%. So you'll be getting here 2 marks. Okay, we are going to the next question. Okay, and then for C here, concentrated sulfuric acid is a dehydrating agent. They absorb water, so which can chemically remove water from substance. Now we have both hydrated copper 2 sulfate. Okay, it's hydrated, and sucrose we have this, which can be completely dehydrated by concentrated sulfuric acid. This is a dehydrating agent. So what happens if we remove the water from this hydrated copper to sulfate? It will become, okay, please remember this name. This one is the name here is okay, this hydrated, right? It's the opposite of a dehydrate. Opposite of hydrated will be anhydrous. Anhydrous, and you just copy this one, copper sulfate. It means this is a dry. They do not have water molecules there. Okay, so for sucrose, if we remove the water, you can see the formula here. If we remove the water, so balance you will have only carbon. So that's your answer here. Okay, so see, you have 2 marks over here. Okay, next we move to the last question for question number 3. Okay, for D, when a propan 1-ol is heated with a concentrated sulfuric acid, this dehydrating agent as a catalyst, and unsaturated carbon of relative molecular mass 42 is formed, and one other product. Okay, so this is the basic concept where alcohol, alcohol, and here you'll be getting alkene and plus with water. Okay, so this will be plus with water. So D is this process is called as a dehydration. All right. Okay, what is the mean by term unsaturated? Means you will have there is double bond exists. You can say that double bond exists, or you can say that none of not all carbon bondings. Okay, you can say like carbon bondings, carbon to carbon bondings as a single. If all of the carbon you have a single bondings, it means it's saturated. Okay, write the chemical equation for this reaction. So we can actually follow this. Okay, this is a propan. Propan means it's a C is 3, and the formula for alcohol, let me scroll down a bit. Okay, formula for alcohol is CN H2N plus 1 OH. Alkene is CN H2N. So when they mention about propan, write this equation, we just substitute the 3 to the end. So we will be getting here C3 H7 OH, and then here we will be getting the same number. Okay, so you'll be getting the C3 H is 6, and then we just have to plus with water. Okay, these are the reaction. Okay, name unsaturated hydrocarbon formed. So this is propane. Propane. Okay, so we are getting here 1 mark, 2 mark, and 1. So total marks for question number 3 is 17. Okay, I hope you can understand this. Now we move on to the next question. Okay, question number 4. This question is about reactions of base and acid. Ammonia is a gas at a room temperature. So what's the test for ammonia gas? Describe positive results of this test. Okay, to test the ammonia gas, we have to use a damp litmus paper. Okay, litmus paper. Okay, the results, because ammonia gas, it shows alkaline properties. So the red color litmus, okay, red litmus changes to blue color. Okay, because of this alkaline properties. Alkaline properties. So you have 2 marks over here. Okay, let me scroll down. Okay, for B, ammonia reacts with water to form ions. So the equation, if you notice here, this part, ammonia, it become ammonium ion. So how this happens is they accept hydrogen, ion to become a ammonium ion. So this is a proton acceptor. Okay, how does this equation shows ammonia behave as a base? So this is your answer, proton acceptor. Okay, aqueous ammonia is described as a weak base, suggests a pH. So pH 7 to 14. Okay, this is an alkaline. Okay, alkaline. So 12, 13, 14 is a strong. It's a strong base. So your answer should be in between 7.5 to 11. So let's say we just put there around 9, pH of 9. Okay, then you got this 1 mark here. Okay, describe what is seen when aqueous ammonia is added to aqueous copper 2 sulfate until no further changes is seen. Okay, so here the answer will be ammonia, or you can say the aqueous ammonia reacts with copper 2 ions. Okay, copper 2 ions to precipitate light blue. Okay, light blue copper hydroxide will form. Okay, copper hydroxide, and I will write here copper CO. Okay, this is the precipitate that will form. So what happens is, the next is ammonia. Okay, ammonia, let me scroll down. Okay, ammonia causes this copper ion to go back into the solution as deep blue ammonia, solution, ammonia solution. Okay, so here there is a keywords I'm going to highlight here. Okay, it will precipitate light blue copper hydroxide. So this is actually a blue color. Copper 2 positive is in a blue color. Okay, so what happens is they will form a precipitate at first, and then this ammonia will cause the copper ion to go back to the solution as a deep blue solution. So this deep blue solution will remain. Okay, that is a few points over here you have to remember when ammonia, aqueous ammonia, is added to any aqueous copper ions. Okay, so I hope you can understand this. This is a 3 marks question. Next we will move on. Okay, for C, aqueous sodium hydroxide is strong alkali that reacts with dilute sulfuric acid. Let's write down the formula here. Okay, isotopically, what type of reaction? When you have a base and you have an acid, so this one is a neutralization. Okay, this is a neutralization process. Now complete the equation for the reaction between both of them. Okay, so here what we have here you will have salt at this part, and here you have water. We can just write water here. So for the salt, Na, okay, Na positive, and sulfate ion will exchange their ions, and you will form here Na2 and SO4. And then here we have to look at balancing the equation. Balancing, so sodium is 2, here's 2, solve. SO4, here's SO4, same. When we look at hydrogen, here we have 2, here we have 2 hydrogens and 2 here. So we just have to balance this water molecule into 2. Okay, so your equation has been balanced. You got the 2 marks. Okay, we move on with this next one. Okay, for question D, a student wanted to find concentration of some dilute sulfuric acid by titration. Okay, this is the method they used. Student found 25 centimeter, this is the volume, 25 centimeter cube of 0.04 of sodium hydroxide. React exactly with 20 centimeter cube of acid. Okay, in titration, name the suitable indicator used in titration. So normally they use is a methyl orange. Okay, methyl orange indicator. Okay, here's the calculation part. Okay, all this they are actually referring to the formula above, the equation that we have solved above here. This one, this is the equation. So let me copy down this equation down here. Okay, the formula I have written here. Okay. Okay, calculate the concentration of acid in molarity here using the following steps. So first question is calculate the number of moles of sodium hydroxide in 25 centimeter cube. So what is other information that they have provided us is this. So the concentration of sodium hydroxide is 0.04 mole dimetric cube. Okay, the mole dimetric cube. So we have this volume and also this molarity. So there is a formula to calculate this. We can use mV divided with 1000 to find the mole. Okay, to find the mole. So here this M stands for molarity, which is 0.04. 0.04, alright, and then the V here is stands for the volume in centimeter cube, which is this. So we got here 25, we divide it with 1000. So this is the steps to find the mole here. So the mole that we obtained is is 0.001. Okay, this is the mole. So we can write it here 0.001. Okay, now when we look at the formula, okay, the second question, they mentioned deduce the number of mole. Now they are asking the mole of acid that reacts. So if you look at this formula, right, the ratio of sodium hydroxide is 2 given by this, and the acid is 1. So we can make a simple ratio here. Okay, so we have to divide. Alright, so these two is given by 0.001. However, this one you have to divide to make it equal. So this should be 0.001 divided by 2. You'll be getting here 0.0005 mole. Okay, that is your answer for number of mole of a acid. Okay, 0.005 mole. Okay, let me scroll down. Okay, now the last one, calculate the concentration of acid in molarity. So what we can do here is, okay, the acid here is given by the volume. The volume is 20 centimeter cube. okay, 20 centimeter cube. So we have to change this to dimetric cube by dividing 1000. So we'll be getting the V is a 0.02. This is a dimetric, okay, dimetric cube. So the formula for mole and dimetric cube is mole divided by the volume, dimetric cube. So the mole here is, we already get here 0.005 and divided with 0.02, and you have here the answer 0.025 mole dimetric cube. So this is the concentration of the acid. Okay, now we look at the last one. Calculate the concentration of 0.04 mole dimetric cube sodium hydroxide in gram. So based on the knowledge, mole to mass, to change this, alright, we have to multiply with the RMM. Same goes to this molarity. So we got mole dimetric cube and we have to change to gram dimetric cube, right? So we have to do the same thing, multiply with RMM. So here 0.04 multiply with the RMM. So the RMM here is given by sodium is 23, oxygen is 16, and hydrogen is 1. So we plus all here, we will be getting 23, we plus with 16, plus with 1, we will be getting 40. Alright. So 0.04 multiply with 40, you will be getting your answer 1.6 gram. Okay, 1.6 gram dimetric cube. So that's your answer for this question. So you're getting here 2 marks. Total for this question is 16 marks. Okay. Okay, this is the 5th question. Okay, ethanol is manufactured in 2 different processes. For each process, name the organic reactant and state the type of reaction. Okay, firstly, the organic reactant here can be sugar or starch, okay, anything that contains sugar, and they'll be undergoing a fermentation process. Okay, in this fermentation process, alcohol is being produced. This is like beer productions, all the alcohol productions, and also for they can make it for the bread making. Alright, so this one. Okay, another organic reactant is okay, it's under alkane group. This alkane group, by the type of reaction is hydration. They add water to this alkene. So here they mention ethanol, so here should be ethane. Okay. Alcohol can be oxidized to form carboxylic acid, which has the functioning group of a COOH. Okay. Name the suitable oxidizing agent for this reaction. Okay, alcohol to carboxylic acid, they have the suitable oxidizing agent is potassium manganate. So we just have to put here, make sure you write this one is acidified. Okay, acidified potassium manganate. Okay, acidified potassium manganate. So this is the suitable oxidizing agent for this reaction. Now we move to the next question here. Okay, alcohol can be partially oxidized to form aldehyde. Okay, aldehyde is the functioning group is double C double O. Okay, they have a double bonding with oxygen. So this is the functioning group of this aldehyde. Okay, now aldehyde is a homologous series of organic. Okay, partial oxidation is achieved by reacting an alcohol with oxidizing agent in distilled apparatus. Okay, now we look further into their questions. Okay, so name the apparatus A. Apparatus A is called as a Liebig. Okay, so we can make it as a Liebig condenser, because when they heat this substance, so what happens, it will change it into a vapor, a hot vapor. So since there is no way out, they have to flow here. Alright, so here will be the water. Here will be water. So now on the diagram, use one arrow to show where the water enters. So water will definitely enter from here. Okay, so when they enter from here, they will get a steady rise, and the amount of water always sustain the same. So when you have a hot water here, they will get condensed, and here it will change to liquid. So that's why the name is a Liebig condenser. So you got here 1 mark, you got here 1 mark. Alright, I hope you can understand this. Okay, next. Okay, the D, the table shows more information about aldehyde. Okay, complete the table. So this is the names. So let's say you don't know about this. Okay, so we can actually get the information from this table. So you say like C2 is at, C3 is prop. So what are they adding here is all, you have the name anal. Okay, so ethanol, propanol, butanol. So here you have a C1. So here should be meth. Okay, anal, methanol. So here booth is a C4. So we can deduce the general formula for aldehyde. So you can see the O remains the same, but the C and the H will be double up. So here is N, here you just put there 2N, and here's O. So here is C4, H is 8, and here's O. Okay, so that is the formula. So we have completed the table and also deduced the formula for aldehyde. Okay. Okay, this is the structural formula for ethanol. Okay, ethanol, and we have here C double bonding with O at the end of this carbon chain. Is a reactive part. The reactive part means is the functional group. Okay, so what is the name given to the reactive part of any organic molecules? So I have explained the answer. The answer is a functional group. Okay, it's a functional group. Okay, this is a functioning group. So you got here 1 mark. Okay, now we proceed with the next question. Okay, complete the dot and cross diagram to show the electron arrangement of the molecule of ethanol. Inner shell has been drawn. Okay, so to get a better result on this, we have to draw the Levy structure. Okay, to Levy structure, just to explain to you how is this being done. Okay, hydrogen has 1 electron. Oxygen, it has 8 electrons, so their arrangement here will be 2.6. Okay, and carbon, these are 6 electrons, and their electron arrangement will be 2.4. So what happened here is C okay, so I have draw this Levy structure. I haven't completed it. So drawing the Levy structure, it only involves the valence electrons. Okay, so these are the valence electron that I draw. So here So we have another hydrogen over here at this part. So we have H, and then the oxygen, let me draw in a dot. So you have like two dots here, oxygen. Okay, now I'm going to circle them. Okay, hydrogen, they already become stable by having two electrons there. Same goes to each hydrogen. Okay, so here, okay, oxygen, they have obtained an octet configuration by sharing two. You can see there's a bonding here. All right. Okay, now we'll go for the carbon. Carbon, I use the green color. So they have obtained 1, 2, 3, 4, 5, 6, 7, 8. So they have obtained okay, these are the carbon, and another one I'll be using black color for the another carbon. So this is okay. Now what you have to draw is okay. Now they ask us to complete the dot dot and cross diagram, right, to show the electron arrangement. Now you can see I will highlight in a yellow color this part. Okay, you have two electrons, right? The set intersect here. Okay, so there's a two diagram. So here we have to draw like a two diagrams. 0 cross, put a dot, cross, put a dot, cross, and then here you can see there's only two. So just put there dot and dot. Okay, at the oxygen part you have to draw 4. Okay, we have to draw 4 there, since you look at here, this part and this particular part, they have 4 electrons. So I'm going to draw the same thing here. Put a dot, you cross it, cross, dot, cross. Okay, so here they share 2, 2, 2, and here will be 2 electrons, 2, and here will be 4. Okay, make sure this is correct, and you'll be getting here 3 marks. Okay, so I just want to explain here. You can get the correct answer by drawing this Lewis structure. Okay. Okay, propanoid belongs to homologous series called ketone. Ketone has the same C-carbon group as aldehyde, but carbon double bond, this group is not at the end of the carbon chain. Propanol has same molecular formula as propanol. Okay, they have the same molecular formula. So what term is used to describe molecules with different structure but same formula, molecular formula? So this is your best answer will be isomer. Okay, so suggest a structure of propanol. Okay, this one, show all of the atoms and all the bonds. Okay, they have mentioned here clearly that look at here the second sentence, this group is not at the end of the carbon chain. So what you're going to do here, okay, first we draw the carbon. You got C, C, and C, and it's not at the end of the carbon chain. Okay, so this group, the functioning group here, is not at the first carbon or at the last carbon, so should be at the middle. Okay, so just remember, carbon you must have maximum 4 lines, 4 bondings. It means like you have 1, 2, 3, another one. So here is already full. So here will be additional one more, and here will be 1, 2, 3. So now I'm going to write down the hydrogen here. Okay, you have 3 hydrogen on this side and 3 hydrogen on this side. So we have the C3, H is 1, 2, 3, 4, 5, 6, and O is 1. So we have successfully drawn this, and this is your 2 marks here. So total for this question is 17 marks. Okay. Okay guys, so we have successfully finished discussing chemistry paper 4, 41. This is a May June 2020 paper. So I hope you enjoyed the video and it can help for your revision. Okay, all the best for your coming exam, and I hope you can get a good understanding of this paper. So please subscribe us to get for further updates. Thank you very much for watching, guys.